I want to present a talk about, I call it API-driven platform. Who has seen the API firsthand already of Kubernetes in some way? Few hands. So this is about the API. It's not about launching pods or creating services. It's about the API, the concepts behind Kubernetes. When you say kubectl get services, for example, what happens behind the scenes? And it's a platform, so platform means you can build on top of that, and this happens a lot at the moment. So everybody who has been in Copenhagen at the KubeCon beginning of May, there were talks with 300 people listening to controllers and custom resources. And this means that there's a huge demand and many companies building on top of Kubernetes, using it as a platform, not only as a container manager of some way. I'm Stefan, working for Red Hat on Kubernetes. So I'm lucky to go every day for a few years now. STTS, some might have seen those nicknames. Does it work? Yeah, it does. So I start with this overview slide, but it's actually not that important today. What is Kubernetes? If you install Kubernetes, you usually get something that's called a control plane here. So control plane means there's a controller manager involved, a scheduler, and an API server, and etcd. Everybody who has deployed etcd manually, that's the beast. That's the hard part, the small box here on the left. We just assume we have all of that, but actually we don't use much. We don't use a controller manager today and not a scheduler. We only consider or look at the API server today. In a normal cluster, of course, you have the nodes. So you have kubectls, which run the Docker containers. And you have kubectl, which is your CLI tool. So when you, on your notebook, you use kubectl or kubectl, as some people say. And all of those use the API. So that's at the core of Kubernetes. So I brought here the kube API server. And it has a big, huge API. This grows every release. I think you need 10 slides just to show all the endpoints or something like that. Everything which is done in Kubernetes, so every component, I painted a few here, uses the same API. Nothing is hidden. There's no secret path between kubelet and API server. Everything is open. You can use the same API for your own tools or whatever you want to do. Of course, there's security involved, so you maybe cannot do everything because your account cannot access certain endpoints, but in theory, you can. This includes, no, it doesn't work, it does. This includes your kubectl. Kubectl just issues API calls. This includes the nodes, so the nodes have kubelet and proxy. It includes pods, so you might deploy something natively on Kubernetes, some database, for example. This might talk to the API. Operators, you've heard of that maybe. All the master components, the control plane components, scheduler, controller manager, all talk via the same API. And even the API server itself talks to itself via loopback connection via the API. So this is at the center of Kubernetes. This makes up a tree, of course, all the HTTP paths here. So we don't use gRPC. It's all HTTP based because at that time there was no gRPC. Maybe today we would choose a different way. Everything is, looks like that. So APIs have endpoint APIs here, and then there are batch jobs, for example, and below version 1 there are jobs, there are namespaces, there are cron jobs, all those things. You might have network, for example, some subtree for networking. You have a core API. We call it core, and it has a special path here, just API. It's not under the APIs for historic reasons. Before we had those APIs, those so-called API groups, we thought, we will only have one API. Let's put it here, and this is just API v1. All the core tools, so all the pods you find under API v1 today. It's called core API. So it's maybe we'll change that at some point. Don't know. So what is Kubernetes today? Kubernetes today is API server, as I said. So I go to the terminal here. I hope you can see it. There are many tabs open. At the top right, I've started an etcd, so very simple, just by calling etcd without any arguments. Everything is without security today, so no certificates involved. This is, of course, not the suggested way to do that. And I launched a kube API server with a minimal arguments. Again, I disabled everything around secure ports. I use HTTP and some flags I have to pass here. I don't talk about that today. And for simplicity, I use the etcd2 mode, just a detail, and we store everything as JSON. So let's start that. Now we have an API on the local host. And you can use kubectl, get namespaces. The default namespace always exists. And we can look at it with some objects. So I zoom in. It's a JSON object. They always look similar, so I don't go into many details today here. But this is how such an object usually looks like. And this here is a namespace. So it's a kind of namespace, version v1. It has a name, default, some resource version, and some stuff below, which is not important today. And it's active, has a status active. So this is an API server. So we have used one of the endpoints of Kubernetes already. If you want to see what really happens when you call such a command, very helpful, just increase verbosity. We use glog for historic reasons. We don't like it, but we use it. If you increase it to 7 or something more, you see what really happens under the hood. So there's a request to this URL. You can use curl and access the same URL. You get the same JSON. Nothing secret. If you use kubectl create, you see a post call and so on. So everything is just standard REST. What else did I list here? Yeah, you can annotate all the objects, so you can just do that here for the example. So there are certain standard properties. Let's get kubectl. So you can annotate every object with some key values you like. You can use that for your own tooling. So if you write a deployment system for your application, you can use annotate to store state on objects. So I do that here for the default namespace. Meetup is hello. And if I now look at the namespace, of course, we find here an annotation, meetup hello. This is just a key value store inside of each object you have. And this looks already like could be a platform. You could build something against that. And that's the goal of the annotations. And as I said, you can do everything, of course, not only with kubectl. You can use curl or your favorite programming language library to access that. And we also have clients, of course, Go clients, especially because everything is Go in Kubernetes. And yeah, maybe a last thing. So everything is etcd here. Everything is stored in etcd. So I switched to version 2 for simplicity. And we can just look into the etcd kubectl ls, and you see a lot of key values. And somewhere should be, here is the default namespace. So under registry, namespace is default. And if we look at that, this will not surprise you much. This will just be the JSON again. So this looks really simplistic, I think. This is Kubernetes, the core of Kubernetes. Focus, I think, maybe. It does. So this we have seen already. You can, of course, script everything here, for example, with JQ to modify JSON. And you can get the object, change something like change that annotation, and then put it back, just with curl, HTTP, something like that. There is one interesting property of our system. So it's distributed. So you have many services. All of them might write to objects. So we have to make sure that somehow consistency is guaranteed. And we use something that's called optimistic concurrency, which means you get an object like this default namespace. You change something like this JQ, metadata annotations, meetup equal to random. You wait. In my example, I wait a second, and you write it back. And you can imagine if you have this loop, this bash loop twice in a terminal, they might overlap, and they might overwrite the changes of the other one. What happens is, I mean, this doesn't happen because there's something called a conflict. And the mechanism we have is using something called a resource version. We saw it here already. If I say kubectl get namespace, we have a resource version. So you get the object, you get resource version 474. You change it, you wait a second, you write it back. And etcd will notice whether there is a new version already. If there is a 475, 475, or something above 474, you will get a conflict back. So this is something completely normal in the system that you have to be prepared when you get something and update it, you get a conflict, 409 in HTTP. Be prepared for that. If you write a controller, try it again. Try it 10 times, something like that, 5 times. And if there are not too many participants around, at some point it will succeed. The core concept, it's nothing bad, it's by intention. A few words about the HTTP paths here. So all of them look like that, APIs, then some API group, batch jobs, for example. Then we have a version, v2 alpha 1, that's a schema we have for versions. If it's a stable version, it's v1, of course. We have v1, beta 1 quite often, and we have those alpha versions here. And then we have the resource. So if I want to have the jobs, jobs are one-time containers. So they run once until they succeed, and then they go away. You can use it for cron jobs, for example. Yeah, this is the style, the schema for the paths of objects. I'm a bit lazy here in the talk, so sometimes I forget or intentionally don't write namespace defaults. So everything is a default namespace. This is part of the path, of course, but I forgot it sometimes. So namespace resources, so pods can be put in namespaces, services are in namespaces. This was mentioned in the talk before. This is a way to separate objects in your cluster. This is part of the HTTP REST API. The version, this is an important part. The version here, it's written in each object, v2, alpha 1, in this example. I write a pod, so in this example, it's a job, not a pod. And the version changes, of course, over time. So if you deploy a new Kubernetes, there might be a new version of an object suddenly because the API changed. But your code might use an old version. We will see in a second how this is realized. There can be 2 versions in parallel or 3 versions even. And your code will still keep working. Before we go to that, there's one distinction I just want to mention briefly. We talked about resources. Those are those plural words here, jobs or pods or services. And there's a word, it's called, or a term, it's called kind. They mostly overlap. So for a job, there is a kind job. The kind is usually uppercase and singular, and the resource is plural. One resource is about the HTTP API path, and the kind is about the logical object. Why do we have that? It can happen that at one path you get a different object sometimes. Status is a very common one. There is a kind status here at the top. Somehow this doesn't work sometimes. No, anyway. So at the top here, the light blue one, it's a status. So if you do something, it can be that you just get a status back, not an object. So at one path, at one resource, there can be multiple kinds. That's why the distinction exists. I said we can have multiple versions in parallel. Each object exists at all known versions. And there is dynamic real-time conversion between them. So if you create a pod or a job in this example in version v1, another client or another colleague with kubectl can use an old version and get the beta variant of that. So you create it in one version and you query it in an old version API, and it's converted in real time. This is very specific for our API infrastructure. This guarantees, of course, that objects, even if you deploy a new Kubernetes, they are still existing in the old version. So if you write code today against v1 beta 1, and in the next Kubernetes it's v1, no problem, your code will keep working. Everything is real time. Every object exists in all versions. This is very hard to guarantee and implement. So if you want to use Go and implement such a thing, this is not trivial at all. Because you shouldn't lose anything. So I vote lossless conversion. So every conversion between those versions, don't drop data. You must go from V1 to V2 alpha 1 and back. And there shouldn't be any data loss. If fields disappear or appear, then we used to use annotations to store the temporary values, which don't exist as a field. So those tricks exist. Yeah, as I said, it's not trivial. And all of those are, of course, available on those REST pairs here on the left. Pointer doesn't really work with multi-screen. So here on the left, the backup job, the nightly backup job, can be queried in each of those 3 versions, 3 endpoints in the API. There are more conversions involved. I don't go into details here. When it's written to the etcd, of course, one version must be selected. It's always one. So we write usually in usually in the stable version. So even if you create a v1 beta 1 object, it's converted to the stable usually. But if you query it in the v1 beta 1 again, it's converted back. So you don't see it. But in etcd, you usually see one version, which is usually the GA, the stable one. And everything I show today, it's JSON. We use protobuf at quite a lot of places. So kubectl will talk protobuf, in fact, not JSON for performance mainly. And also in etcd, usually you will not see JSONs, but protobuf, which is a bit harder to debug. So if you look in the production cluster, you will find some binary blobs there. It's harder. So far, that are the principles of Kubernetes APIs. And I said I don't want to talk about pods, about container management. I want to talk about being a platform for anything. And there's one topic for everybody who wants to implement custom concepts, custom resources. It's called custom resources. There are 2 concepts. I write them here both to make clear there's a difference. We talk about custom resource definitions, and we talk about the custom resources. You will see in a second what this means, where the difference is. What you want to do, we want to store something custom. So we're in Iceland, we have volcanoes. We want to store volcanoes, maybe from some devices which measure something on the volcano, something like that. You could imagine use cases for that. And we use an API version. So we selected Iceland meetup.com v1. And the kind is volcano, uppercase, singular, as I said. Yeah, what else? We call it, so this is one instance of a volcano. So we use the most famous one, Eyjafjallajökull. And yeah, it has a spec, so it has a height. Of course, I looked it up in Wikipedia. It's in South Iceland, and it's a stratovolcano. It has a status, so all the information from your devices which are on the volcano and measure something. Last eruption was in 2010, I read. It's considered still active, so we write that into the status. And this difference between spec and status you find everywhere in Kubernetes. So spec is the declarative state of the object, which it should be, and status is everything which is reported back. And there's magic behind, so controllers, that's what we call controllers, which make sure that the status matches the spec. So in this case, you could have a controller which calls your devices on the volcano, gets the information, and writes it into the status. That's the idea. We want to store those in Kubernetes. We want to say kubectl get volcanoes. So everything we have seen for jobs or for namespaces before, we want to do with volcanoes today. This is a custom resource. And you can imagine we have to define something now in the system. We have to tell Kubernetes we want to store those custom resources for volcanoes. And to do that, we use custom resource definitions. That's a declaration of those. Just a very quick view of Kubernetes. So custom resource definitions you have in every Kubernetes. Every Kubernetes, which is, I think, 1.7 or later, has those CRDs. We call them CRDs in short, custom resource definitions. If you deploy the kube API server, which we did in the terminal before, it has some subcomponents in the same process. Especially, it has the kube resources, so pods, services, and stuff, everything for containers. And it has a third component. It's called API extensions API server. And this is about CRDs. This makes sure that CRDs can be created and stored in the same etcd. So Volcanoes will go into the same etcd as pods or other resources. Yeah, we want to store that. So I go too fast. No. So to declare in Kubernetes, we want to have Volcanoes. We create a CRD, and the CRD is also an object. Custom resource definition. It's in some API group again, so it's in some HTTP path on the API server. It's called API extensions KS IO. It's still beta. We don't have a V1 of CRDs. We might have it in the next half a year, maybe. And we tell Kubernetes Volcanoes should, so there's a name for this object, and they should be in this API group. They should be in version 1. The kind is Volcanoes, Volcano. Plural is Volcanoes. I found out there are 2 spellings. I have no idea. The US people can tell me which one is correct. One with the E and one without. Kubernetes is not clever enough to derive that, just for simple cases. So if you want to write Volcanoes with the E in the middle, you have to tell him. You can do it here. And scope is namespaced. You can also say it's a cluster scoped, but we put Volcanoes in namespaces. So you can have one namespace for South Iceland and one for Highlands, whatever, some distinction like that. And the name of the CRD is just derived. So the name is just the plural, so the resource name and then the API group. You create this object in the, so you say kubectl create -f, this file which you just saw. And a few seconds later, the API server will accept it. So it will check the names. Are they consistent? Are there no conflicts? So you cannot reuse the name like pod. Doesn't make sense because then it's not clear what you really mean. So there are checks involved. And if everything is consistent because names are not used, you get those accepted names here. And it tells you condition, names accepted. Also, a very common pattern to have conditions. Always look like that. No conflicts is the reason. Great. No Volcanoes in Kubernetes yet, so we have created them. And established tells us the Kubernetes API server knows about Volcanoes now. So let's do that on the command line. So I start Kubernetes cluster. You can use any Kubernetes cluster, so you can use it on Azure, on Google Cloud. Minikube is a very, very often used tool locally, which starts a local cluster on your notebook. So we start that, and then we create the resource. So he's compiling. Let's go forward. So this is what we want to see. So we want to see that kubectl now knows about Volcanoes. So we can say kubectl get Volcanoes -v, so glog level 7 again. And then you see what really happens. So kubectl does the following. First, it notices I don't know Volcanoes. So what are Volcanoes? Let's ask the API server, what can be Volcanoes? So what it does, it goes to the API's path. There's a JSON behind that with all known API groups. It will see, oh, there's a new one. It's called Iceland Meetup.com and version 1. So let's query what is in this meetup group, in this meetup API group. So it queries this URL. There's another JSON, and there is a Volcano. I think I have a slide. I do. So here are some excerpts from the JSON, the discovery info, that's how we call it. And so here's our group. And if you go further into the group V1, you find there is a resource called Volcano, name is Volcanoes. It's namespace, everything we just defined for this custom resource. So let me see, it's still compiling. And after those 2 steps, it can go to this path and really query all Volcanoes. So it does a list. It's a get call. It's a get verb in HTTP, so nothing special. But the URL has no name here, so we don't ask Volcanoes / Cutler or something like that, some Volcano. But it just, the root URL for Volcanoes, so it's a list. And kubectl sees there's nothing. So there's a list which is empty. it tells us. And yeah, this mapping, so mapping volcanoes to kind volcano and resource volcanoes, and then to the API group, and deriving this long path here, this is called REST mapping. So if you start writing a controller, you might see this term REST mapping. It's just this mapping from a word which is incomplete to the full specified kind and resource. And yeah, if you want to have special names like the Icelandic plural, you can also have short names. So it's like an alias for volcanoes. For many resources, we have that. You can say replication controllers are RCs, for example. Kubectl get RC is REST mapped to replication controllers. The same you can do with Jökla here. In fact, I noticed you have to write O, so it must be, cannot be Unicode. This actually doesn't work, so it must be Jökla or with E or whatever. So 2 steps if you want to use your own custom resources. First, create the CID. We have done that. It's this object, and if you have done that, kubectl knows about it, and you can actually create a volcano. So let me see whether we can just play that here. Not yet. So I have to kill my etcd because the script here starts its own etcd. Hope it doesn't take too long. Our build system is not very fast. Yeah, I mentioned it already. Spec status, use that if you define your own resources. You can, of course, put any data in them. So you can put any keys in every shape, every schema you like. But there are certain features which require that spec and status are there. Usually, a user can only write to the spec, but he cannot change the status for security reasons. The user shouldn't fake any status. This is a system which should do that, write the status. And to make the distinction, there's something called sub-resources. I don't go into details, and for that you need that. So follow the conventions. There's a document in Kubernetes describing all the concepts, how those objects look like, things like conditions which we have seen, how they look like, when they should use, and so on. This is all kind of standardized. So I think now we have a cluster. I have to change the context, so I changed to my new cluster. I don't use the Kube API server we had before. I started a complete cluster now. And now we say I want to create the Volcano CID. This modified for testing, so I put in Jökla and I notice it doesn't work. So let's put O again and create. He's happy. We can see how it looks like. Get CIDs, there it is. So everything which we defined here, the names are correct. So he's happy. Here's a condition somewhere. No conflicts found. It's established. True, established is true. That's fine. And I also put something here, validation. I show it in a second what this is. And now we can start our create call for the volcano. I have your Jökla, and now not have it. I don't have it. Kube control get volcanos without the E. We see it there. You can also look at the YAML if you like. Everything we have seen, and some more stuff. So we have seen the resource version for this optimistic concurrency before, and there's a creation timestamp and other stuff I don't talk about today. But we have those resources in our system. Cool. There's one feature, don't poll the API. If you write something, some tooling around, there's something called a watch. So you can have an event-based interface. So you can, in the simplest case, you just use kubectl get volcanoes minus W, and it will not show the objects, but you get event stream. And you can use whatever logic around to do that, to process that. Of course, everything is REST API again. So it's an infinite HTTP connection, and you get JSON fragments for every event. Every change, every deletion, every new object, you get an event. And you can use your Go tooling around to do something in real time. So the user creates an object, like a volcano, and you deploy a pod which carries your device on the volcano automatically. Those things can be implemented like that. So use watches, don't poll, of course. Validation. So until now, everything is just JSON. Any arbitrary JSON, if the user makes a mistake, yeah, you will not notice. There's just JSON stored in etcd, a JSON blob. That's usually what one doesn't want, and for that reason, we have validation. Validation, so it's a field here. You can define it in your CRD. So you can say validation and then OpenAPI v3 schema. That's the name because it's based on OpenAPI. OpenAPI is a standard to define APIs, REST APIs. It's easier to look for JSON schema. There's a standard called JSON schema, and this is basically JSON schema with some additions and some things which are removed. And this is how it looks like. So here's one example. So the spec and the status of our example volcano. And we can specify that this is an object which has properties, and one of the properties is spec, one is status. Spec is again object, has properties. One is type. So here is the type, stratovolcano. Type is any of. So any of, I have just one example, some regular expression here. For the stratovolcano, of course, if you have an enumeration of 7 different volcanoes, you can put all of them there. One of them, any of, must be fulfilled. So it's a contour, how we call that. The height is an integer. It must be at least 0, nothing negative. Location is a string again, and we don't support defaults yet, but we might support that in 1.12 or something like that. We're working on that. And you can say every object must have a type, must have a height, and must have a location. If one of those is left out, the user will get an error. A similar error like this umlaut, which I wrote for the CRD. Similar errors you would get if a user conflicts with your definitions here. And the same for status. And if you have defined that, which we did here in the command line, is it here? It's this long definition. So we have validation, and I don't show it now. If you change something and it doesn't validate anymore, you get errors. So consistency. Don't be afraid. This is a deep dive picture from another talk. There are other systems or mechanisms like admission, and which can be used for validation as well. If you want to check more complex things in your objects, you can use admission. And validation is somewhere here in the middle. So if you don't know what admission is, it's not so important. It's one step in the API server. CRDs are limited. That's what you always read. So we will see a talk about service catalog. They started before CRDs existed, and they started before those crossed out features didn't exist. So we started with hardly any features, but we changed that, of course, over time. So 1.7 was the first version. Now we have 1.10. 1.11 is nearly in code freeze. So yeah, we have seen a couple of things already. We have seen validation, for example. This is in since 1.9, was a Google Summer of Code project. Admission, I mentioned. It's not alpha anymore. It was an alpha API before. Now it's beta. So every cluster has CRDs. So every GKE cluster has CRDs. So you can use that for product development, if you like. Service catalog will be such an example. Yeah, and we add more and more features. There's custom printing. So you can say kube control, get volcanoes, and you get custom columns like name, last eruption, and so on. So you can define in the new version, which comes out in 2 months' time or something like that, you can define that. So a custom output of kube control get. Yeah, and as I said, demand is high for CRDs. They're a very active and wanted feature. Some words about controllers. They are nothing secret, nothing complex. We have seen some on the slides already with some bash code. Basically, a controller is nothing else than a loop. It reads an object, it changes an object, it writes back the object to the API server, and it goes back to the first step. Nothing else. Hopefully using watch, don't poll, use watch. So don't hammer on the API server. Watches are there to solve that. And a simplest controller. A controller is no rocket science. A controller is, in the simplest case, just a bash loop, like we have seen here. Or Go or Python or whatever, if you want to use, or you should use clients, of course. We have typed clients for all the objects. You can also create Go clients for CRDs. So then you have real Go structs. So it's not a dynamic map string interface like if you use JSON unmarshal. It's a real object, a struct, which is pretty easy to use. That's all available. This is a basic example for a watch controller in Bash. Don't use Bash, use Go or something like that. Outlook, most of those things I've shown already on the slides before with the red lines. So we add something called multiple versions in 1.11, but without conversions. So if you want to have conversions, you don't get them yet. We will add them, but slowly. There's something called pruning. I don't go into details. Basically, it's about if you don't have a field in your open API spec, then the field doesn't exist. And if a user posts you something with an unknown field, it's dropped. It's like if you have a pod and you put in foo equals 42, the foo 42 is not stored in etcd. And the same will be true in CRDs. Server-side printing, that's about kubectl get customization. Sub-resources, it's beta now since 1.10, so you can have spec and status independently and define permissions on them. And it's going further, of course. So declarative field renames, we will probably add graceful deletion. Defaulting, I had in one example in red where the validation schema was printed. So we are working hard on that to make it better and better. Yeah, that's it. CRDs. If you have ideas, so people use them in enterprises internally. It's a cool tool to write your custom controller logic, some magic around deployment scripts. That's a perfect tool for that. People build products. So those 300 people at KubeCon, half of them build products nowadays in some startups. Or Service Catalog is thinking about using CRDs. It's a cool tool, and it's even cooler to see that so many projects start to use it. Thank you. Questions? Yes. For example, you could have, so the question is how it's really used in practice. So I think Service Catalog will have something like a service. You will see that. Every object for this product will be an object which is based by CRD. So behind that, there's CRD as a storage mechanism. In a company, you could have something like you want to deploy your application. So your deployment could be a CRD. Configuration for your application could be a CRD, including validation. So you could have a JSON for configuration of your application. And the user uses kubectl to edit that, and he gets validation because you can define it in the CRD. There are serverless frameworks where a function is a CRD, and the serverless framework sees them. It watches all functions and does the magic behind the scene. Yes? Yeah. Yeah. I think it's still a problem, but with a solution. So if this is really a problem because you have high load on those objects and etcd is not fast enough, I showed this API server or this API extensions -API server. This can be compiled as a standalone thing and put into the cluster. So you could have your own special API server with an own etcd backend if this is really a production issue for you. So by design, this is possible. We don't do that at the moment, but if CRD usage goes up and you have high load on them, this will be a thing, I guess. At the moment, it's baked into the Kube API server, but there's no reason to split, not to split that. Would be done. Yeah, it's still integrated using aggregation. So you speak to the same API, but it's forwarded to your custom API server and then using a different etcd if this is a bottleneck. So if you have big systems, maybe this would be a way out of performance problems. Yes. Yeah, it's this picture basically here. The Kube API server, it has in front the first box, it's a Kube aggregator, and this can forward to your custom API server. And this can have a custom etcd. So the design is really meant to be flexible, and if performance is an issue, you would have ways to do that. Not by default. By default, everything is for simplicity in the same API server and same etcd. Here was a question.
Sense. Source.
So there are always config maps. So configuration is often also stored in config maps. There are free-form data, which is mapped into a pod or a container. You can use that, but you don't have validation for free. With CRDs, you have validation, and you have all this kube control magic, this UI, basically, which is pretty nice. If you want to have a native serverless framework, CRDs are just, they are a tool to make this native, to feel native. Yes?
It's really
Yeah, so a controller and operator are nearly the same thing. I asked that at KubeCon some people who use the operator term. I think the distinction is just a controller which manages another software, does some admin work, if you like, in an automated way. This is an operator, but it's just a special purpose controller. It's nothing fancy. Yes, yes. An operator is a special controller which uses the same API, the same tools. There's an operator SDK by the core as people now Red Hat, which makes it easier. So there are tools around that to make operators easier. But at the end, it's nothing more than those bash loops. There's nothing special about them. Further questions? If not, I would say we make another short break, like 5 to 10 minutes, so we can change the computers and you can get some more beer. And then we continue with Jeremy's talk.